All right, opening up to page 396 in your math textbooks. We're going to kind of touch on today some graphing with some quadrants, and a lot of this is probably something that you've worked with before, so we will fly through it probably. All right, so looking at this graph right here, okay, this coordinate plane. What you may not already know is a lot of the times you'll just see one part of it and you'll be able to, or be asked to graph up there. We're going to be working with 4 of those now. So this is actually a whole coordinate plane, and then the quadrants, usually we just work in quadrant 1, like we have earlier in this unit. Now we're going to be working with 4 of them. So when they are referring to these different quadrants, they are numbered so that we know exactly where they are. So I'll write this a little bigger. This is quadrant 1. And the reason why they start here and work backward is because this is the one that, or this is the quadrant that we always refer to as. A lot of the times this is what data ends up being in, so that's why they numbered it number 1. So then 1, 2, and we work backwards, and then down is 3, and then quadrant 4 is right here. So they give you that in Roman numerals, but 1, 2, 3, and 4. And if you look, you have a point right in the middle where all 4 of these, or the x, or all 4 quadrants, or the x and the y axis intersect at. We know this as the origin. So I'm going to draw a little arrow out here. This is the origin, and its coordinates are always 0, 0. Okay, so 0x, 0y. It doesn't move anywhere to the left or the right or up or down. Remember, x is our first one, y is our second coordinate given to us. So x and y is left and right, or x is left and right, y is up and down. Okay, so quadrant 1 is always going to have positive x and positive y, because you're going to be moving to the right and up. And in graphing, to the right and up is both x, or positive x, and positive y. Now, if you are in quadrant 2, your values are going to be negative and positive. So your x will always be negative and your y will always be positive. Quadrant 3, it'll be negative, negative, and it's kind of complete opposite of here. So negative, negative. We have a negative value, you're going to the left, and then you're going down. Quadrant 4 is always positive, negative. So again, it's the opposite of the one kitty corner from it. So positive, negative, because you're moving to the right and down with your coordinates that you're given. And that's what this whole chart over here explains also. Positive, positive for quadrant 1, negative, positive for quadrant 2, quadrant 3 is negative, negative, and quadrant 4 is positive, negative, just like we worked with here. You might want to use this as a reference, and it really does a nice job of explaining and identifying the different parts if you are stuck on a problem. So when we're given an ordered pair, what we do is we start at the origin with our ordered pair. And we then move, depending on positive or negative, left or right, what the coordinate is giving us. So this one here says, let's identify the pair that names point C. So we're going to try to find what the coordinates are for this point right here. We're going to start at the origin. We're going to move right because we know what's up here, so we have to move right and up. And this is labeled a little differently. It's not labeled 1, 2, 3, 4, and 5 like we're used to. It's just like what we talked about in a ratio table or on a number line. You can have these numbered, however, as long as they are following the same pattern. So that's what they're doing here. So we have 1/2, 1, 1.5. And I know that that's where that intersects with. So my x-axis, or x-coordinate, is going to be 1 1/2. Okay, we always have our coordinates with a parentheses and a comma in between. So now we're here, and we need to move up. So we have up 1/2 and up 1, because that's where that intersects with here. So our ordered pair, which it says right down here, would be 1.5, comma 1 for point C. Let's find what point A would be. Point A. Point A would be negative 1/2, negative 1, because I know that that's right lined up with that. So we have C, A is negative 1, and we have to go up still, so it's going to be a positive value. We have positive 1/2, positive 1, positive 1 1/2. So negative 1, 1.5 is what A would be labeled at. B, let's label that one. B, we're going to go left and down, so it's going to be negative and negative. So we have negative 1/2, negative 1, negative 1 and 1/2. Okay, and then we're going to go down, so negative 1/2, negative 1. So we have negative 1 1/2, negative 1 as B. D, let's label D. D is now down in quadrant 4, so it's going to be positive, negative for our coordinate pair here, or ordered pair. So let's see, we have to go to 1/2, 1, 1 1/2 in order to go down here. So we have 1 1/2 is our x value, positive, and then we have to go down, negative 1/2, negative 1, negative 1. So it's 1 1/2, negative 1. We have one more, let's practice with E. This is in the same quadrant, so it's going to be both positive and negative again. So we have negative 1/2, 1/2, 1. And then we go down, negative 1/2, negative 1, negative 1 and 1/2, negative 2. So 1, negative 2 would be the ordered pair for spot E, or for the point E. Okay, so now reflections on the coordinate plane is what we're working with next. Guess what? They have a number line here, and this is exactly the same thing as finding the opposite, of a number, except it's now on a graph and not on a number line like we were given here. So last week I said, all right, find the opposite of 2. If I was told to find the opposite of 2, you found 2 on a number line. And you said, okay, that's 2 spaces away from 0. So now the opposite would be the same distance away from 0, just going the opposite way. So now if I'm going from 0 to 2, I'm going to go from 0 to negative 2. And I know my opposite of 2 would be negative 2. You are going to be using that same exact concept, except it's just going to have some more boxes that you're working with and not just one row or one axis here. So let's say you're given the ordered pair 1, 1. We'll just start with that. Okay, 1, 1. Let's find where that is. So we started our origin and we go to 1 and 1 right here. Now if it says reflect that across the y-axis, y is the one that goes up and down. You're going to find that same ordered pair just on the opposite side of y. So that means it would be right here. Okay, it's exactly the same distance away from the y-axis, and it's exactly the same distance away from the x technically, but you're just reflecting it over the x-axis or the y-axis. So it's kind of like you have a mirror standing right in the middle. My fingers are a little too fat. Standing right in the middle of your graph. Your double-sided mirror is going to show you where your ordered pair is on this side, and it's also going to reflect that same pair on this side. So where would that on this side end up if it's a mirror image of it? And that's what it's asking. So now if you're reflecting across the x-axis, it would be the same thing. You're just flip-flopping it from here to here. So let's say we were working with 3, 4. Okay, let's graph that. So 1, 2, 3, 1, 2, 3, 4. So 3, 4 is right here. And if it said find or reflect 3, 4 across the x-axis, instead of going this way with it, we're now going to go this way with it. So now I'm going to find the same exact spot, just the opposite of that across the x-axis. So that means I'm still going to go to 3 because that's still lined up here, but I'm going to go to negative 4 instead of positive 4. So this would be the opposite of 3, 4. But you need to know what axis you're flipping it across or reflecting it across in order to do that correctly. So let's move down to the got it problems at the bottom of 397. It says, name the ordered pair that is a reflection of each point across the x-axis. So if we have, let's use this graph up here. We'll graph it up here, even though this has nothing to do with this down here. So 1, negative 4. Let's graph that. So we started our origin, we move over to 1 because that's positive right here. And now our y value is negative, so we're going to go down 4. 1, 2, 3, 4. So this is where C is. I'm going to label that C. And it says we're reflecting it across the x-axis. So that means we need to find the x-axis right here, and we're going to flip it across the other side. So it's going to be the exact same ordered pair, just in a different spot on the graph. So that means because I'm reflecting it across this, my x-axis is going to stay the same because I know it still needs to be in this row here, this column right here. So in order to reflect it across the x-axis, now I'm going to go to 1, and I'm going to go up 4 instead of going down 4. And this is the reflection. We put a little 1 by it here. The reflection of C across the x-axis. So now our new ordered pair would be 1, 4. Okay. A lot of the times, here's a little trick. Whatever axis you're flipping it across, in this case it's the x, that value is going to stay the same. Okay, so the x value, x comma y, didn't change. X didn't change because that's the axis we're flipping it across. But we found the opposite of y because that's what was being reflected. That was the change in there, was that y value. And you'll see 4 and negative 4 are opposites of each other. So let's look at this one. Negative 2, 5. So we're going to go to negative 2 and up 5. So it's right at the top here. So I'll put a little d. And it says reflect across the x-axis. So now it's going to be the same exact ordered pair, just down here instead of up here, because this is the axis we're flipping it across. So that means our x value is going to stay the same, because I know it's still going to be on this row right here, this column, so that's negative 2. But now instead of positive 5, it's going to be negative 5. So that's the reflection. Put a little 1 by it. And that would be our reflection. Same thing with this one. Our x value is going to stay the same, no matter what. Before I even start to graph it and figure out where this is, we have negative 3, negative 1. So that's right here. I'm going to label that E. We have the reflection across the x-axis. So that means it's still going to be in this column right here, like we said, but now instead of negative 1, it's going to be positive 1. So it's going to be right here. The reflection of E would be negative 3, 1. All right, your homework for today. Sorry, that was a pretty long lesson here. You are going to flip to the next page, page 399, and you're going to be doing problems 1 through 13, which includes all of the letters of problem 13. It is super, super simple. All you're doing in problems 1 through 6 is telling me where these points are, or these letters are on here. You're going to give the ordered pair. So I'll do number 1 for you. So let's find where R is, and then we're going to say what coordinate or quadrant it is in. So let's zoom in a little here. And we have R right here. So that means I'm going to start at the origin and go over 1, 2. So I know my x value is 2. And my y value is also 2 because I'm going up 2. And now what quadrant is that in? It is in quadrant 1. We'll use Roman numerals here. So you have 1, 2, 3, and 4. Okay? Make sense? Then the next section, 7 through 12, you are going to be finding the letter of the ordered pair that you're given, and you're just going to write what letter it is and then what quadrant it's in as well. So let's do number 7 together. Negative 2.5. So 1, 2, oh no, I'm sorry. Negative 2.5 is right here. And then we have positive 1.5, which would be right here. So it's Z. And we're going to tell what quadrant that's in. 1, 2. Okay? All right, down at the bottom, you are going to be answering questions like this is a theme park, and this is the map of a theme park, and you're going to be giving either the coordinates or the item that is at the coordinates that it's given to you. So you are probably going to have to do some reflection. I see across the x-axis, and now a reflection across the y-axis, which again is this to this. Okay, x-axis is this to this. All right, let me know if you have any questions.